Hello everybody, today we are going to see the refraction or refraction of light at plane surfaces. So what is refraction, its definition? So we are going to see. Before going to refraction, we are looking towards the reflection of light. What is reflection of light? Uh, in reflection, what happened? The light gets written in the same medium after it strike on the polished surface. This is polished surface. Let us be this is polished surface. It M mirror. Okay, this is A incident light. Okay, it strikes on this surface and it get returns in same medium here. So this is incident light and the return light we called as a reflected ray. This is reflected ray. If we suppose draw a normal name NM, okay, and this incident ray making some angle with this normal, this is small I, okay, and this reflected ray is making another angle at angle R, it gets reflected. So this is reflected angle, this is normal. So what happen in reflection? Lights comes in same medium. This is only one medium. It gets strike on polished surface and return in the same medium. Okay. So this is the reflection. In reflection, we saw two conditions. Their angle of incident is equal to angle of reflection, and this incident ray, this normal and this reflected ray, this all lie in only one plane. This one plane, this plane. Okay, so this is about the reflection. We see now we are going to see the refraction of light. So what is refraction? Refraction means change in the direction of the path of light when it passes from one transparent medium to another transparent medium. It's called a refraction. In refraction, we require two medium 1 and medium 2. Light comes from one medium M1, medium 1, and it gets refracted in another medium 2. So let us understand it with a diagram. This is the diagram of refraction. Okay, here we consider this is glass slab. Okay, this is glass slab, name as S dash. This is normal NM. This is A incident ray. It gets strike on this glass slab. Now in reflection we saw if this is polished surface, the ray returns to only this medium. Okay, means it strikes this incident ray strike on this glass on this surface and it reflected here. That's all we in reflection. Here also some part of light is reflected, some part of light gets reflected. Here this ray is deviated, so this get written in this medium. So this is reflection, and now some light travels in the another medium M2. This is M1. This is medium 1 M1, which we taken as air, and this is medium 2 M2. This is glass medium. So light comes in like this in air medium, in M1 medium. It gets strike. Okay, some of the part of the light is get reflected and some travels comes in the M2 medium, another medium. Now this light must be follow this path. Okay, must be follow this path, but it gets deviated and it follows this path and that like this straight path. Okay, it gets deviated from here. So this is incident ray. It is making some angle with normal I. Now this light get reflected here. So light, this incident ray should be follow this path, but it get deviated here and it travels in this path. So here this reflected ray making some angle with this normal and be called as a angle of refraction. And here is the delta. Here we called it as a deviation. How much light get deviated? Now this must be follow path by light, but it gets deviated towards here, so we get another angle. This is delta, we called as a deviation of light. So in refraction, if we taken as a case 1, let's consider case 1. What is case 1 says? If our medium first medium is rarer and second medium is denser, then when light travels from rare medium to denser medium, this air is a rare medium, and here is glass is a denser medium. So when light travels from rare medium to denser medium, it gets deviated towards normal. Here it is a normal and it gets deviated towards the normal. So here we write here, when a ray of light travels from a rarer medium to a denser medium, it bends towards normal. So here we get angle of R, this refraction angle R is less than angle I. So here is angle I is greater than this R. So angle R is less than angle I, and we get the deviation which we get delta equal to I minus R. This delta equal to I minus R. This is first case in refraction. Okay, now let's go to the second case. Now in case 2 what happened? Here is medium 1 we take as a glass, and here medium 2 we take it as a air. So this becomes our denser medium. Now this is our denser medium and this is rare medium, because this is glass and it is denser as compared to air. So this is a denser medium and this is rare medium. In case 2 what happened? Now this light, now in case 2 this light will come from denser medium. Now it is coming from denser medium, same as previous case. This is S dash glass slab, and this is normal. A is the incident ray. It is making angle I with normal. Okay, this incident ray, some part of light get reflected and some part is refracted. Now this light, after passing through this glass slab, it should be follow this path, but it bends towards that side and it follow this path. So now this part. Okay, so what happened in case 2? When light comes from denser medium to rare medium, it bends away from the normal. This is normal, and this light going away from the normal. So this is case 2. Now in that case, this R, this angle of refraction is greater than the incident angle. So here we note that angle R is greater than angle I. Here we write, when a ray of light travels from a denser medium to rarer medium, it bends away from normal. So we get deviation of ray becomes delta is equal to R minus I, because here R is greater than I. So R minus I. This is case 2. Now let us go to case 3. Now this is case 3. What happen if light is along the normal? So this is our normal. This is same as S dash glass slab. Now light incident ray is along the normal. It is along the normal and it is making 90-degree angle with this glass slab. This is perpendicular. Okay, this incident ray is perpendicular to the glass slab. So what happen if this light coming, okay, in medium 1, let it be air, and it travels in the medium 2. After refraction, the refracted ray gets undeviated. It does not show any deviation, any kind of deviation. It is this comes and this go in same direction. So here we write, ray of light incident normally on the surface separating the two media passes undeviated. It is undeviated. It doesn't show any deviation. So here angle R is 0. Of course it is 0 because it is along the normal. This is our normal and this is our incident ray. So this is what will be the angle between them. It is of course 0 degree. So angle R is 0, angle R refracted angle of refraction is 0. So of course deviation, or the value of our deviation will 0. If we can do I minus R or R minus I, it is 0. So here we write, here angle I is 0, angle R is 0, then deviation must be 0. These are all three cases. One thing I want to tell you, that we know the speed of light. Speed of light is 3 into 10 to the power 8 meter per second in vacuum or in air. In water, speed of light is 2.25 into 10 to the power 8. So here we see in water the speed of light gets low. The speed of light decreases as in water as compared to in air. Its value is high in water and it is decreased, and in glass 2 into 10 to the power 8 meter per second, it is also decreases here in glass. So basis on these values, we say that in denser medium what happens, speed of light is low, it is low, and in rarer medium like air, speed of light speed is high, speed of light is high. Or denser medium we can take water, glass. A rare medium we can take air. Here when lights comes from medium 1 and enter in the medium 2, if medium 1 is rarer and medium 2 is denser, then speed of light is greater in rare medium. After passing through another medium, if light speed gets decreases, then it is called as a denser medium. Here if light of speed is greater, okay, initially greater, and after passing through any transparent medium, if its speed gets decreases, then the first medium 1 is rarer and medium 2 is denser. And contrary to it, if speed of light, initially speed of light is less, and after passing through transparent medium, if its speed gets increases or high, then the first medium we say it as a denser medium, and second medium we say it as a rarer medium. So we see refraction, definition of refraction. It's three cases. We see the refraction. What is refraction? Change in the direction of the path of light when it passes from one transparent medium to another transparent medium. Okay, we see the definition of refraction. We see its first case, when light travels from rarer medium to denser medium, it bends light, the refracted ray or reflected light gets bent towards the normal, and in that case what is the value of I, R or deviation? We have seen it. In case 2, we seen when light comes from denser medium and enters to the rarer medium, the refracted ray bends away from the normal. We see the value of I, R and deviation here also. And in case 3, when light is incident ray is along the normal, so what is the refracted ray? It is passing, it is undeviated, it gets undeviated here. So we see the value I, R and deviation is 0. So it is all about refraction. Okay, in next video we will see the laws of refraction. Thank you.